In this little video, I'm going to look at 3 more functions to differentiate where there's a little bit more to think about. So let's have a look at each of these in turn. So the first one is y equals e to the power 3x ln x. So this is a function of x there and a function of x here. They're multiplying together, but they stand alone individually as 2 perfectly respectable functions of x. So this is a product of 2 x functions. Okay, and our product rule, I'm just going to write it with the u's and the v's. Okay, this is one that you need to know. U times v dash plus v times u dash. Okay, so your first, and well, doesn't matter which way round you call them, but I normally do the first one as the u and the second one as the v. So if you want to write these down and then work out the 2 differentials, keep your work nice and organised. So we need the quick way to differentiate the e, which is you bring the differential to the front and keep the e power the same. And the quick differential of ln is 1 over x. You can just memorise that one, or you can just keep thinking differential over original. And then if we put it into the product rule, let's see what we get. Okay, so my u times my v dash plus my v times my u dash. Okay, let's just try and tidy this up a little bit. There isn't much we can do. Don't be tempted to multiply anything in with this x that's within the log. Okay, so let's just put these terms in front of the ln, just to make sure we're not tempted to times into the log. If you want to, you could bring e to the 3x as a common factor. You don't really have to with this one because there's not any great simplifying that you can do within it anyway. So I don't think you would need to do that to get your marks, but you could if you wanted. Okay, so the second example, we've got y is equal to 3 minus 2x squared over 5 minus 4x squared. So this, hopefully you spot, is the quotient rule. Okay, it's a fraction. Okay, so anytime you have, particularly x is on the top and x is on the bottom. Okay, I mean, it could just be a number on the top. You could use the quotient rule in that case, but there's probably other ways you can do it. But certainly when you have a function of x on the top and a function of x on the bottom, you need to use your quotient rule. Now, the quotient rule is in the formula book here with f's and g's. I tend to write it with u's and v's, so it's up to you. You can follow this though, and it will give you exactly the right answer. Okay, I normally use it with the u's and the v's, and my rule then would be vu dash minus uv dash all over v squared. So my u is the top, so my u dash would be negative 4x. My v is the base, so my v dash would be negative 8x. Let's see what happens as we fill in the bits of the rule then. So my v times my u dash, I'm going to make sure I'm putting lots of brackets, minus my u times my v dash, there we are, all over v squared. Okay, you don't generally need to multiply out the v squared, but you will probably need to tidy up the top. So we're going to multiply out, so we're going to times this out. So we'll get negative 20x and then positive 16x cubed. Okay, we're going to have to be a little bit careful here because we've got a minus and we're going to times these out. So that would give us minus 24x, but then that minus makes it a plus 24x. And then here that would give me a positive 16x squared, but then that gives me a negative, so it's negative 16x squared altogether. Sorry, there's a squared there, isn't there? Beg your pardon. Cubed. Okay, nearly went wrong there. Saved it. Okay, so just shows you've got to be careful copying what you've written. It was correct there and I didn't copy it correctly. Right, so that happens, which wouldn't always, but it did in this case, and we can add these together to make 4x over 5 minus 4x squared squared. And again, no need to do any more to that. That's as nice as we can get it. Okay, so the third one on this page, which I'm going to have to do at the bottom now, is y equals ln of sine x. And I put this one on this page just to show you that it's quite tempting to think of this as a product because you see a log and you see a trig. Okay, but this is not the product rule. Okay, if you cover over the sine x, ln doesn't kind of make sense on its own. It needs to be ln of something. So this is a function within a function. Okay, a function of a function. So it is not a product. So don't use the product rule when it's not a product. Okay, you need to be able to, coming back to this first example, you need to be able to sort of see them quite distinctly as separate x functions that exist in their own right. Okay, this one is simply just a log differential. So going back to the log rule, the rule is that we differentiate by doing the original function on the bottom and the differential of it on the top. Okay, so it's not going to take much room. I can put it in here. dy by dx is going to be a fraction where the differential's on the bottom, sorry, the original's on the bottom, and then the differential of the function is on the top. So the differential of sine is cos, and my answer is just cos x over sine x. And if you're feeling very on the ball, you could write that as cot x as well.